Very well. Today we'll explain what we call SpaceX's orbital brain, the artificial intelligence that will manage the Starlink V3 network. Let's start with the basics. Starlink is a constellation of low-orbit satellites that delivers internet to places where fiber can't reach. It doesn't rely on cables running to your doorstep. Signals travel via radio between the user's antenna, satellites, and when needed, ground stations. With laser links between satellites, data can hop from satellite to satellite through space and only travel where needed. Light moves faster in vacuum than inside fiber optic glass. That's why, for long distances, this route can be faster than terrestrial path. Our home antenna isn't a rotating dish, it's a phased array antenna with about 1,280 small elements that combine their signals to form a highly concentrated beam. That beam is electronically directed with micro delays. It tracks satellites crossing the sky without engines or moving parts. Now, what does Starlink V3 bring, and why is it a key advancement? Here's where the change happens. Basically, it's about size and power. A V2 mini satellite weighs up to 800 kilos with a solar wingspan of about 13 meters. A V3 weighs about 2 tons and when deployed reaches 60 meters. This larger surface generates much more energy for maximum operation. It also has greater capacity. A V2 Mini offered download speeds of about 96 gigabits per second. A V3 is designed for 1 terabit per second download and 200 gigabits per second upload. That's over 10 times the download speed and an even bigger jump in upload. There's also a difference in thermal management and reliability. The V3 has much larger radiators to dissipate heat and maintain power without throttling. Additionally, critical modules like transceivers and processors come in redundant configurations. If one fails, the backup kicks in. The launch is also affected. Due to their size and mass, V3S don't fit on a Falcon 9. They're designed for Starship. A single flight can deploy around 60 V3 satellites. If each adds roughly 1 terabit per second download speed, we're talking about 60 terabits per second added with just one mission. Regarding orbit, V2 minis operated at around 550 kilometers altitude. The V3S operate lower, at about 340 kilometers. Being closer means latency consistently stays below 20 ms, averaging 12 to 15 ms, comparable to good fiber. This makes online gaming, demanding video calls, and other real-time tasks viable. Lowering the orbit comes at a cost at 330 kilometers, where there's more atmospheric drag causing the orbit to decay faster, requiring more propulsion to maintain position. This shortens the satellite's lifespan, so the strategy is to compensate with frequent replacements using Starship. That covers the hardware. Now for the orbital brain. How do you coordinate thousands of nodes moving at roughly 27,000 kilometers per hour in a constantly changing network? It's about capacity management. Internet demand isn't uniform. A city at night has high usage. The Pacific Ocean at that time doesn't. AI analyzes historical patterns and real-time traffic to predict usage spikes. It also uses laser mesh routing with optical links between satellites. There are many possible routes for each data packet, and finding the optimal path considering load and latency is a complex problem. We can leverage distributed reinforcement learning, where each satellite learns in coordination with its neighbors. That's what artificial intelligence does. It also works on optimizing each connection and serves as an orbital autopilot, okay? It also enables more predictive maintenance as AI reviews telemetry data from the entire fleet. Voltages, temperatures, performance metrics. Using anomaly detection models, it identifies failing components, switches to backup systems, and flags that satellite for replacement in the next launch before users notice any issues. Let's summarize with one clear idea. With Starlink V3, we shifted from fitting technology into a rocket to designing our ideal satellite and building the rocket to launch it. More solar area, more heat dissipation, redundancy, a terabit per satellite, lower orbit, and laser links that make the constellation a global mesh network. On this hardware, AI functions as a brain. It anticipates demand, shifts capacity, selects routes, manages the fleet, and when needed, creates dedicated services. The result is an orbital cognitive network with fiber-like latency and global coverage. This is what the orbital brain governing Starlink V3 means. So tell me, what do you think about this new update from Starlink? We're already seeing AI applications not just in robots but in cutting-edge technologies like internet connectivity. So let's see how it goes.